Please join me in welcoming Dr. Joe.
Thank you, Barbara, and congratulations on the recent award. That's fabulous, and I'll show you right out of the gate just how important this is to help get get pollution out of the water. So anyway, thanks again for the invite. It's a great pleasure. I'm speaking to you from Vermont, so not very close to the coastline, but I've worked extensively in the North Atlantic, in the North Pacific, including in a little bit in California, but more in Washington State and in Alaska and Hawaii. I'll talk a little bit about that later on. The nice thing about this kind of work is it brings me to many different places around the world. And I grew up in New York City and Long Island, so I grew up along the water and have a fondness for islands and coastlines. All right, let me share this. Uh, how does that look, Barbara? Are we in? Is that work? You're good? Okay. Great. So, as Barbara said, I'm happy to take questions. The only thing is with my full screen, I'm not sure if I'll see the hand up. So, Barbara, you're going to have to moderate. Feel free to just interrupt me. More than happy to take questions and make this a conversation, or I'll just keep chatting for a while and we'll see how it goes. So on January 29th, and let me clean this, in 2019, a 37-foot whale stranded in Everglades National Park in Florida. Now, it was a baleen whale, like gray whales or humpback whales that you'd be familiar there. It's got those throat grooves. This is in the Gulf side. So there are very few baleen whales found I'm going to say the Gulf of Mexico. I'm going to stick to it. You guys can correct me if you want. In the Gulf of Mexico. So scientists came out, they did a necropsy. They found that it was an adult male with no external signs of trauma. So it hadn't been hit by a ship, it hadn't been caught in fishing gear, which are two ways that whales can die by human causes. And interestingly, the DNA, they did a DNA analysis, it matched this small group of non-migratory baleen whales found only in the Gulf of Mexico. So it's mostly found in the just off the coast of Florida. Not it goes as far west as Alaska, but the majority of this very small population is in that area. And what they found was the DNA for this individual and the others closely related to it were so different that it's actually a new species. So the result of the sad stranding, in part, was some more scientific information about these whales. It's one of the rarest whales on Earth. There's only about 50 individuals. And not only did they find what species it was, but they also found the individual. And on the right-hand side, this is witch hazel, who is the male that died. A picture had been taken the year before, so they even know what individual by the markings on the skin and on the fins. It was listed as endangered in April 2019. So they put the species on the endangered species list. It's also protected by the Marine Mammal Protection Act. But the question was, what had it died from? Here's the sad news. When they did the necropsy, they opened up the stomach and they found a piece of plastic about 5 inches long, about the size of a credit card, probably from a 5-gallon bucket. So the pieces had broken off. The whale had swallowed it and it had caused necrosis in its stomach chamber and it starved and it died. So amazingly, even a small piece of like plastic like this can put whales in danger. This is the risks of life in the ocean these days, and I'm glad Barbara and others are there. One, trying to remove that after you have a tragedy like the fires in the West, but also trying to reduce the amount that get into the oceans in the first place. Um, It's, as Barbara said, it's 5 o'clock somewhere, 5 o'clock for you guys. That's the sad news. The good news is for many whales and many species, we have turned it around in my lifetime. Many populations of whales are now far more abundant. Almost all whales were endangered in the 1970s as a result of commercial whaling. And Raymond Chandler, who's lived in Southern California, he said all great crime stories are stories of redemption. So I'm going to talk to you a little bit about this redemption. That's the black-footed ferret, which kind of looks a bit like a masked criminal, which is why I keep it on this page. All right, so great whales. This is an image from National Geographic from several decades ago. They once comprised 90% of marine mammal biomass across the world, and they were found everywhere. They migrated from the Arctic to the equator or from Antarctica into areas off of South America or Africa, so they're moving all the time and they're feeding in high latitudes, and often many species breed in lower latitudes. So I see a few faces there. You probably have any of you seen migratory whales like gray whales in your area? I'm suspecting for many of you, you've seen those whales migrating, whether they're humpbacks or gray whales. When I say great whale, I'm talking about two groups. One is the baleen whales. Those are the filter feeding whales. So those are the ones that feed on krill. They have that long baleen. Think of a right whale, a humpback whale, a fin whale, a blue whale. And then we also include, they're evolutionarily distinct, and we also include the sperm whales in there, largely because of their size and in part because of the cultural history we have with sperm whales through whaling. So they're everywhere. Some scientists called it the cetosphere at that time. The ocean was so full of whales that it was basically a whale ocean. That all changed starting about 1,000 years ago when the Basques started hunting right whales off the coast of Europe, and then was really the biggest hunt was in the 20th century. On the top is the northern hemisphere. At the bottom is the southern hemisphere. You can see that there were far more whales in the southern hemisphere than the northern hemisphere. It's a large ocean and the hunting was intense there, and the different colors show you the different species. Humans first started hunting some of the largest ones like blue whales in the 1920s, and also fin whales and sperm whales, some of the largest animals ever to existed. In fact, blue whales are the largest animals that have ever been on the planet, right? So we hunted those at first in part because it provided either more food or more oil. And then populations started to decline severely in the 1960s. We basically hunted the biggest ones, the smallest ones, until we get to the minke whales in the 1980s, and whaling really starts to disappear. Things started to change in the United States in the 1960s. At that point, great whales, about 85%, so almost one out of every five whale on the planet, was hunted because of commercial whaling. I promised you that things would get better. So in the early 1970s, I spoke to Lee Talbot, who was in the Nixon White House. I didn't speak to him in the 1970s. He was there in the 1970s. He told me that there was an interest in protecting endangered species, and he chose the marine mammals first because they were charismatic, they were rare, even though he cared also about freshwater mussels or freshwater fish. You weren't going to get a freshwater mussel at Protection Act. The problem with protecting marine mammals at that time was that sperm whale oil was used for lubrication. We weren't using it for light anymore because that had been replaced, but it was still used in lubrication in submarines, in NASA rockets. It was the best lubrication they had. Lee Talbot, who was again in the White House at that time, he went to Dow Chemical and got an affidavit from them that they could produce oil similar in properties to sperm whale oil. He brought that affidavit to the Joint Chiefs of Staff, And they said, okay, if we can get the oil that we need, the Commerce Department, the Defense Department said, let's do it. The next year, the Marine Mammal Protection Act is put into place. And that is protecting all marine mammals, including whales, including seals, sea lions, as well as polar bears. So all the mammals that live in the ocean. So first step to really making a big change to how we treat whales. About a decade later, it took another decade for the moratorium on commercial whaling to be passed throughout the world. This was by the International Whaling Commission. So at that point, 1982, complete ban or moratorium on whaling. Some countries continue to whale because of either they objected, but for the most part, whales are protected throughout most of the oceans. And indeed, now it's not whaling, intentional whaling that puts these whales in threat. It's more other human activities, plastic in the ocean, ship strikes, fisheries entanglements, ocean noise. But the great news is when you stop killing whales, something really important happens. They come back. This for me, since I was a kid to now, when I talk to students, they can't imagine an ocean without whales. But it was true. I mean, there were 1,500 humpback whales in the entire North Pacific in the 1970s. There are now more than 21,000. I'm guessing many of you have been on whale watching trips and have probably seen a humpback in the North Pacific, especially in Hawaii and Mexico. Hawaii, where they go to breed, and they tend to feed in that northern, off of Alaska and the north. So less than 15 years, 14-fold increase. This is a humpback mom and her calf off the coast of Hawaii. Very successful change. Another species that you guys would probably have seen, eastern gray whales recovered from about 11,000 in 1994 when they were protected. They had been lower before that to about 27,000 in 2016, and they were taken off the endangered species list. Another great success story for this species. It's not just whales that have been protected either by the Endangered Species Act or by the Marine Mammal Protection Act. Another California species, don't know if any of you have seen them, northern elephant seals. Here's an incredible story. In 1900, they were heavily hunted. There were only about 20 northern elephant seals on the planet. They had been hunted that hard. In 2014 and more recently, there are now about 180,000. So from 20 to basically as many as there ever have been in that ocean. That is thanks to these protections, but also treaties between Canada, the United States, and Mexico to protect this and their habitat. And then another incredible success story is the sea otter. I know they don't get quite as far south as if you guys are there in LA. I don't know where everyone is right now, but they're of course found. They're found off in Central California and in Alaska. Another species that was down to only maybe 1,000 individuals. It had once numbered hundreds of thousands, heavily harvested, um, only found in one remote island, the remote Aleutian Islands. In the early 1970s, during when there was nuclear testing going on, the Defense Department wanted to test a nuclear bomb on Amchitka Island in one of the Aleutian Islands. There were several thousand sea otters, and the local biologists in Alaska, this was before Alaska had oil, it had good biologists, but it didn't have much money. They're like, if you guys test these, you're going to have a problem because you're going to have a lot of dead sea otters washed up on the coast. We can help you with that. We can translocate these sea otters to areas where they were historically. So they moved several hundred sea otters from the Aleutian Islands to British Columbia to Southeast Alaska to Washington in the early 1970s. This was, you all have probably heard the term rewilding, returning species to areas where they used to be found. This is one of the first cases of rewilding, I think, and really one of the first cases of marine rewilding is transporting these individuals by U.S. Defense Department to these areas and then released. Another amazing success story. There are now 50,000 descendants of sea otters that were evacuated from Mchitka. If you all have seen any north of California up to Southeast Alaska, they're almost certainly the kids of these translocations. One out of every three sea otters in the North Pacific is from that movement. Now, this is a little different than what we were talking about earlier, where the other species that I mentioned, there wasn't much intervention going on. In fact, the key was just to take human pressure off. In the case of sea otters, there was active management, right? Moving them around, and that resulting in a conservation success story. There are often trade-offs. Not everyone loves sea otters. Fishers in certain areas are not fans because they eat about 25% of their body weight every day. So they eat a lot. I mentioned that I'm from New York. When I was growing up in New York City, I never saw a whale. I didn't see a seal. I saw seabirds, but didn't see any marine mammals. I visited my mom a couple of months ago on Long Island and saw whales off the coast there just walking along her beach and dolphins. Nowadays, about two-thirds of marine mammals that we know about are increasing, and about three-quarters of great whales, because of these bans, are also increasing. Other great legislation in the U.S. that's helped these whales is fisheries, the Magnuson-Stevens Fisheries Protection Act, so fish populations increasing, Clean Water Act. Water was miserable when I was a kid in New York, and it's now a lot better. And then also the Endangered Species Act. So these laws really made it possible for these whales to thrive in these areas.
Hey, Joe, is there any
Yeah,
species
great.
that's more critical to recovery than another?
Do you mean because of population size in particular, or?
More critical to ocean recovery, I
Oh, I
guess.
see what you're saying. Yeah, well, I'll talk about that in a minute. But the whales if we're talking about ecological function, and we're almost there, that's where I'm getting there in about a slide or two. The more abundant ones are going to have the biggest impact. I study the North Atlantic right whale, about 350 individuals on the planet. They're important. I'll show you some pictures, but they don't have a big impact on the oceans because their numbers are too few. So the key is we're not just trying to avoid endangerment, but we're also trying to increase their populations. And we'll see, I'll show you in a moment what that kind of impact that could have. Traditionally, and many studies on whale ecology for decades was about whales eat our fish, therefore we should eat whales. They're competition with human fisheries, or they're competing the whales that are abundant, like minke whales, which are the small ones, but were never hunted as heavily as the others, might be outcompeting the larger species like blue whales, fin whales, or sei whales. These images are from the government of Japan. They've been promoting whaling for a number of years now. I saw this slide in the late 1990s. I actually went to Japan and did some DNA analysis of whale meat, and I thought there's something missing in this slide. So I did my um, master's degree at the University of Florida in the late 1990s. I took marine ecology, sitting in the back of the room, and the professor was talking about what's known as the biological pump. What is that? So photosynthesis only occurs at the surface of the ocean because that's where the sun is, right? That's where carbon dioxide is fixed. The phytoplankton or the algae absorb that carbon dioxide, and then they produce, they're producing either cellulose, or they're producing other compounds that are allowing them to survive, as well as feeding zooplankton. So drawing down that CO2, taking it in, and then for the phytoplankton, and then either providing food for zooplankton or dying, and that drops that carbon out of the surface and can sequester carbon deep at in the deep layer of the oceans, deep ocean or the ocean floor. That's the biological pump, right? And that's really important for carbon sequestration in the oceans. I was listening to this though, looking at the way everything moves down, and I thought at that time, there's something else going on in the oceans that I see every time I go out to research. A few years ago, we were insulating our attic, and I managed to find one of my notebooks, and I found the drawing that I did on that day in class. I don't know if you can see it, but it's basically right whales that I studied. They dive deep in the Bay of Fundy. They come to the surface because they have to breathe, of course, often with mud on their heads or their bonnets. So they're at the surface. It's clear they've been diving to the bottom to the seafloor there. And often they breathe, they digest, and just before they dive, they poop or they release a large fecal plumes that can be almost as large as the zodiacs that we were driving at that time, large fecal plumes. And I thought, well, so okay, this is a different than the biological pump, right? In this case, whales are bringing nutrients up, not that much carbon, but they're bringing nutrients that are important in the oceans, like nitrogen and iron are two nutrients that are essential in the oceans. And it's those nutrients that tend to run out in the summertime. So you get this phytoplankton bloom, it runs out of nitrogen, and then the bloom stops. Whales, I thought, are actually maybe counteracting that and helping phytoplankton grow, and then there, as well as copepods, which are the invertebrates that they feed on. Even in this drawing of that first day, I thought on the left there, what about when there were 10,000 whales? Because there are only, as I'd mentioned, 350 right whales in the areas I was studying. What is it like when they were orders of magnitude more abundant? And then on the right there, you can tell I was a graduate student because I wrote 12, 20 equals 8. I had to remind myself or schedule in my lunchtime, my lunch break. So, a couple of years later, I met with Jim McCarthy. He's a biological oceanographer. He died a few years ago, sadly. He was one of my very important mentor. He was a biological oceanographer that was willing to entertain this crazy idea that whales might actually have this influence on ocean ecosystems and increase productivity. Rather than eat all our fish, they may be helping to grow phytoplankton and indeed even fish populations. So biological pump on the left, carbon sinks through feces migration, death. On the right, what we described as the whale pump. Whales feed at depth in the dark, come to the surface where they release feces and also urine. Okay, so kind of a cool idea. How relevant is it? As one of my colleagues said, sure, Joe, I don't deny that there might be nitrogen in this feces, but is it akin to a fart in a hurricane, or is it ecologically important? So what we wanted to do is show how important is this. So we built a model for the Gulf of Maine. That's where we worked. That's the Cape Cod on the left there. And what we found is whales return a lot, more than 24,000 tons of nitrogen per year to the surface. What does that mean? It's a large number, more than all the rivers combined, right? And indeed about as much as humans might put in through sewage, though that's put in a different way. And atmospheric deposition is largely also human caused. That's through pollution that goes out into the atmosphere. So whales are having, we argued, a large effect in these areas. We submitted the paper and it was rejected. In part because one of the reviewers said, look, you guys are right there in the ocean. You've just built a model. Where's the field work? Show us what's actually in these feces and show us how it's working. It's kind of the last thing you want to hear as a scientist, but we kind of knew he was right. So the next summer, we went out and started collecting whale feces to look at these nutrients there. And popular science caught on and called it one of the worst jobs in science, whale feces researcher. This is based more on a lot of work that my colleagues have done. You guys are all fans of the ocean and diving, I assume. So I still consider even a bad day on the water. Well, for me, a good day on the water is collecting 3 or 4 fecal samples. That's a banner day. Um, Even though whale feces can be a little stinky if you get it on your clothes, well, I would say, a good day a bad day on the water is better than a good day in the office anytime. So, if you don't believe that whale feces is really cool, I will try and show that with these slides. So it looks different depending on what kind of whale it is, what it's eating. Sometimes it floats at the surface, sometimes it sinks, that sperm whale, or not sinks, but sometimes it disperses quickly. On the lower right, it's a feces from a calf that was that was nursing on its mom. But you can see these great diversity of species. I had mentioned earlier, I'm sitting here in Vermont, um, close to the home of Wilson Bentley, who was the first person to photograph snowflakes. And he said, every snowflake is unique. I think it's the same thing for whale poop. Every poop that we find is unique, and I'm always thrilled to see it. Problem is, it's kind of hard to find when you're out on the water. Especially if nowadays with drones, it's a little bit easier, but you're on a boat, you're low to the surface, it's kind of hard to see unless it's floating. So colleagues of mine at the New England Aquarium suggested maybe there is a way we could optimize collecting these. So what did they suggest using? They use sniffer dogs. So this is Fargo, who was a 90-pound Rottweiler. He started his career as a companion dog to an elderly woman, and when she went into assisted living, he started working as a sniffer dog in Washington State prisons looking for drugs. So that was his sort of second career. And then I think his third career would be for many dogs a dream job. He became a scat detecting dog. And he started out on grizzly bear feces and also looking for cougar feces and other types in the West Coast. And then colleagues of mine suggested if it works on land, maybe it'll also work in on the water. And there's a North Atlantic right whale that I had mentioned right there. Fargo could find those scents. Unfortunately, he got seasick, so he had to take Dramamine before he went out. Fortunately, his handler was a vet, so she knew what she was doing. And he could find these samples at quite a long distance. His colleague, Bob, was terrified of whales. So Bob only lasted as a scat detecting dog on the ocean for a year, and then he retired to a farmhouse in Vermont. So this gives you an idea of how this detection works in the ocean. On the right, you see a scent cone, and that um, the black square in the upper right is where Fargo detects the scent. He's excited, his tail's wagging, he's on something, and then when you see the X, that means he's sitting down, he doesn't smell it anymore. So the boat driver is changing direction, you're going upwind. Advantage on the ocean is that you don't have hills and you don't have trees that can interrupt the smells. Disadvantages, of course, the dog can't run and follow as you would often see a dog sallying looking for a sample. So the driver's got to do that. And also, there are currents, and of course, in the ocean, so it's hard to know exactly where you were. But you can see that they hit it again, then they go off it down at the bottom there. That black circle is when humans can smell it. So we can smell whale feces about 100 meters, 100 yards. Fargo can smell it at more than a nautical mile away. And that's where he finds the sample there. So he increased the amount of samples that were collected per day by 2 or 3 times, an incredible asset to us in finding these samples. And the good news is, or I wouldn't be talking about it, there was a lot of nitrogen in the fecal samples, also a lot of iron, as well as phosphorus. So, 3 elements that are important in the ocean ecosystems, just like you put nitrogen and phosphorus in your garden, it's very similar. We think of whales in some sense like gardeners in the ocean. They're releasing those nutrients from the bottom where they're locked in for the summertime because of a thermocline up to the surface where phytoplankton can pick it up. So, good news is confirmed our hypothesis, and now there have been studies around the world on this, including the Southern Hemisphere, studies from the North Pacific, finding similar patterns of increased productivity when whales are in the area, contrary to the claims that whales eat our fish. Sure, sometimes they compete with us, but they also have a positive impact on the resilience and productivity in the oceans. So I've been talking about dogs as the technology that was used about 20 years ago. Now drone technology has really changed things. So this is, oops, oh, sorry. Um, this is a fin whale in the Gulf of California. So not far south of you, and they're dropping a tag on the back of a fin whale. And this is a suction cup tag. And you can see the whale didn't even react. So the drone drops this tag, and now it starts to give us a totally different view of the ocean. You'll see it in a minute. You guys are divers, so you know if you're just looking at the ocean from the surface, you learn a lot, but not as much as when you get in the water. You can't, for the most part, dive with active whales. Swim fast. There are some places where people swim with whales, but we don't. We generally do the work at the surface. But now that we have these suction cup tags, we get an idea of whales, what they're doing at depth. Basically, it's the boring stuff that is the surface. It's the cool stuff that's going at depth. So I'm going to show you a video that one of my colleagues in Hawaii put on the calf of a humpback whale. And so you get an idea of what it's like from a whale's eye view. And I don't know if you're going to hear the sound. A friend of mine put some music to this. If you do enjoy it, if not, I don't know why we're going. Sorry about that. Huh. We had you there. Come on. Well, you get to watch this beautiful drop again, and then hopefully we'll get there. Okay, so now this is going to be the point of view of a calf. It also has the suction cup tag, and I'm hoping that it's going to work this time. Come on, I don't know. I'm sorry, guys. Don't know why it got. Huh. I'm going to scooch out here for a second, see if I can move it forward. There we go. Okay. Nope, nope. Sorry for the technical challenges here, guys. Got a source. Okay. Are we back in?
Yeah, we are.
Okay, now I'm gonna hope it works. Fingers crossed. Yes. Okay. Great. So lower right is a humpback whale calf. Up top is mom. These are mackerel scad that are feeding on the skin. And this is really exciting to me. The whale mom is peeing there. So you see that green? We rarely ever get to see whales pee. Lots of nutrients in pee too. They're also feeding on the skin. You can see little pieces of skin. Whales are constantly sloughing. So you've got, and that's milk. So there's leaking milk there. So the calf is nursing on mom right now. Mom's at top. Fish are all excited. There you see mom's pectoral fin. And this is the breeding area in Hawaii. And you're seeing a little more milk there. You see some white clouds. So calf is feeding again. And this is a friend of mine who put some music to this. I don't know if you can hear it. Okay, calves can't hold their breath. Moms can hold their breath for a long time, but calves have to come up to breathe more often. So calves coming up to surface, and that's Maui in the background there. Breathing, taking a breath. There's mom on the lower left, keeping an eye on her. That's the boat on the left that you get a very brief glimpse of, which are the researchers. And there you go, and you get another glimpse. So that gives you an idea. You can see how kind of, to me, it's world changing when you start to go, oh my, oh, this is what it's like. Whether it's from a calf, we also have amazing other animal cams from the moms as well. So now we're getting an idea of you saw that urine, so that's a good, that's a little foreshadowing for what my next project was. But also you're seeing now the relationship between these animals and the fish. Oh no, you come on. I don't know why it doesn't want to forward. So I'm gonna have to get out here again. Sorry, I got that, guys. I cannot explain that. Barbara, how's that?
Good.
Okay. I'm gonna
Yeah.
hope it's forwarding. Otherwise, I'm gonna apologize. So I've just shown you the whales on their breeding grounds in Hawaii. The whales feed in Alaska. They go to the north often because there's where all the food is. Lots of productivity. The water isn't as clear as it is in places like Hawaii. That's because there's a lot of nutrients and a lot of productivity in that area. Whales bulk up. They're called capital breeders. So they feed for a few months a year. They're just whales are just feeding all the time, the moms especially, but also the wannabe dads. And then they're migrating to places like Hawaii where they breed and they don't feed at all. So that's what we mean by capital breeders. Humans and most other species are income breeders. We have to feed when we're breeding. We can't, you can't take a few months off. Only very large animals can do that. When they're in those southern areas, though, or in those lower latitude areas, what I'm interested in is the ecology of this. What does this mean? They are bringing nutrients through their carcasses. Infant mortality in whales is pretty high, like it is in other mammals. So calves die at a higher rate than the adults do, but adults also die there. So they're bringing nutrients from these high nutrient areas to these low nutrient areas. Placentas, whale placentas can be 200 or 300 pounds, so they're very large, and you see sharks and other fish feeding on it. And then we didn't know that when we started this study, it's mostly the urine because whales are peeing. You die once, you have a calf once every 2 or 3 years. But you're peeing all the time, and it's the nitrogen that's important. That's why these areas are low nutrient areas. It's a lack of nitrogen in those areas. So this is work that we just put out a couple of months ago. We chatted about this whale pump, which is vertical. Now there's also this conveyor belt, which are very long distances. Whales have the longest migration of any mammal on the planet. They can travel more than 10,000 miles a year. So they're traveling really long distances, bringing those nutrients in their bodies. And now the question is, yes, okay, it was a problem with the video, so we can move forward. I showed you a whale carcass with sharks feeding them on the previous slide. And those are important in those shallow water areas. But when whales die, it's really important in the deep sea. Why is that? Because the very deep sea there's not a lot of food down there. When a whale dies, it can be the same amount of carbon and other biomass as would fall down to the bot, sink down to the deep sea over 1,000 years in one pulse. You get that in a dead whale. 100 species only found on whale carcasses. I'm showing you one there, which is Osedax on the upper right and the center. That is the bone-eating worm. They're found in the many thousands on the carcasses of whales. Unlike the animals we've been talking about, Osedax doesn't have a mouth. It doesn't have a gut. It doesn't have an anus. What it does is it has a root system. It's a worm, a root system that's embedded in the bones of the whale, and they're taking sulfides and other nutrients and providing it to bacteria in their what would be similar to a gut, and the bacteria producing the food. So it's a mutualistic relationship. These deep sea animals, and those are sea cucumbers you see there, as well as the worms, hundreds of species only found here. Not only is it what carcasses matter when they wash out or sink to the deep sea, but also when they strand. These are polar bears here, and they're feeding on a bowhead whale in Russia. One bowhead whale carcass is equal to about 1,300 ring seals, which is the normal prey for a polar bear. So you can see why they're all there. This is a huge feast for polar bears when whales die. Humans used to feed on stranded whales as well. You all are in California. One species that depended on whale carcasses was the California condor. They fed largely on marine mammals until those populations declined. Then they started feeding more on land mammals, but they were really important to both the Andean and the California condor. So today I've been talking about a couple of these, what we call them ecological pathways. One is whales as predators, which has been the focus of many studies. Also, this nutrient transfer, the work that we focus on, and then carcasses. It also has an impact on the trophic or on the predators themselves. Can change when whale populations decline. Killer whales are one of the only real predator now of these large whales. And we're seeing a return of that predation now that whale populations have increased. They don't tend to attack adults because adults can fight back, but they tend to feed on the calves. So these are the ecological pathways. Oh, stop. Okay, that we've been discussing. And Barbara mentioned I've been focusing on these nutrient subsidies. In the most recent book was called Eat, Poop, Die, and it's looking at how animals impact our world. Whales are one example, seabirds are another. I mentioned sea otters, brown bears, migrating salmon. Animals are moving around all the time. We often think of plants as the lungs of the planet. I argue that animals operate like the circulatory system. Oh, good. And here is a map. You see these moving lines of all tagged animals around the world. Summer's coming in. You can notice in the northern hemisphere, those that you see the northern movement. Now, as fall happens, you're going to see movement back towards the equator and towards more southern areas. These are all tagged animals, whether it's a sea turtle or birds or different species. But you can see how that metaphor of the circulatory system can work. I think the whales help explain that, but it's not just true for whales. It's true for many species. And one of the things that I do as a conservation biologist is think about not only preventing extinction, which is incredibly important, but also restoring these ecological pathways, returning health, restoring the health of the planet. And one way we can do that is by restoring animal populations. Huh, it's something about this. The slides. I don't know why they don't like me today. Um, Okay, no more video. It's something about the video. This is just about the last slide. So we've been talking about the movement of nutrients by whales and other species, but it's all the animals around the planet. As we rewild them, as we restore them, they have an impact on nitrogen cycling, on biodiversity, and even on carbon sequestration. So by restoring everything from whales to bison to wild horses, we see these shifts to cougar populations. We see um, ecosystems rebounding and to some effect, a small impact on climate solutions. And with that, I want to thank you, and I'd love to hear questions or comments or whatever. Thank you all very much.
Thank you. That was amazing.
Mhm. Oh, thank you.
So,
Apologies for the, I don't know why the videos weren't happy, but you're welcome. Great.
any what do you think as far as the weirdest fact you ever learned about writing that book?
What was that? What was the worst fact I learned?
Yeah, the weirdest or most
Oh,
surprising.
weirdest. Oh, you know what's kind of cool is since you all are divers, is in Hawaii and other places, and I forget the exact number, when you're sitting on a beach, you're inevitably sitting in parrotfish poop. The parrotfish are feeding on mostly on dead corals and on corals. And then probably some of you have seen it when then there you see a lot more, they're defecating sand. And I think in some places it's as high as 80%. So 80% of the sand, it comes from animals, not just erosion the way as it does in other places. So for me, that's one example. One sad story is one reason I think that we don't think of animals as being that important is their wild animals are still pretty rare on the planet. I showed you some success stories, but about 60% of biomass of mammals in the world is cows, sheep, and pigs. And
Hmm.
humans are another about 33%. So it's just a small percentage that are wild animals. So my dream after learning these pathways is how can we restore these animals and bring them back so that they're also playing an important role.
And is there anything that we as divers, be it scuba, free divers, or ocean lovers, that we can do to help whale recovery?
Um, yeah, it's part of it is legislation, and part of it is, well, one would be the work that you're doing, which is restricting plastic. I would be mindful, and I don't think that as the diving community is having that much of an impact, but mindful of noise pollution. That would be more of an issue probably with whale watching boats or something like that. I don't think the dive boats are getting that close, typically to the whales. And then, just generally health of fish. There's some evidence that using reef safe sunscreen. Think being mindful of what you're putting into the ocean when you're diving. Though I use reef safe sunblock when I dive or when I'm snorkeling mostly. And also pushing for strong legislation to protect these animals.
So go ahead and come off mute if you'd like to ask a question. You can raise your hand or just come off mute. I see krill now marketed in places, and I just can't believe that. That to me just seems like the wrong thing to be marketing as health products.
Yeah, that's right for omega-3s. I agree. There's been whales in the southern hemisphere are finally returning, and by just taking their food out of the system is a very risky move. So I agree. I'm worried. I hope it's very well managed, and I hope that most of it stays in the oceans. But I would agree that's an issue. I see that Michelle asked, is there another creature that needs the attention brought to it? Probably all of them. In a way, I have an easy job because I'm talking about whales, which to me are cool, they're large, they're charismatic. Most people have seen them, or at least many people that are interested in oceans know them. Corals, there's one for sure, and I'm sure that wouldn't be a surprise to you, but coral reefs are in danger in part because of climate issues. And, we're talking about the influence of animals on the planet. Well, corals create these undersea forests. They're
Yeah.
incredibly important to hundreds, thousands of species around the world. It's just one that comes to mind. I could go on forever, and I love mammals, but I'm also a big fan of the invertebrates. Haven't even talked about plants. Let someone else do that one. We'll stick to marine systems today. We didn't really talk about land animals, um, but yes, there are many. Look at the endangered species list, or look out your backyard, and or when you dive and think about the role these species play. Certainly,
I think you would
and
mind
I
me have
would
a big
go ahead. I see there's a question maybe from Michelle again, or you're back in. Hi, Michelle. You came up. Yep.
Oh, okay. Well, I could ask probably enough questions to take up the rest of the session. So I don't want to do that. So if
Okay.
you get through everybody's questions and there's still time, I'll ask my questions.
So
Okay.
Trish and Steve, you have your raised hand?
Yeah.
Oh, there it is. Sorry. Yeah.
I-
too.
Okay, I've got a question. Are there certain populations throughout the world that are still taking whales?
You mean people?
I mean, like
Yeah.
Japanese or the
Yes.
Norwegians or
Yeah.
even
So,
Native Americans?
yep. So Iceland, but they are not whaling this year. So they've been hunting fin whales and minke whales. They stopped hunting minke whales. Fin whales is legal, but no one's hunting them this year, so that's the good news. Norway still actively kills whales, and Japan both do commercial whaling, and then Alaskan native whaling as well.
Do
And
they,
you know, for what it's worth, I support that. This is historical heritage, so commercial whaling, I question the sustainability of it, and maybe even a bit the morality of it, just from an American point of view. But I support Native American whaling.
are there quotas?
Oh yeah, it's carefully managed. They're bowhead whales. It's very carefully managed and provides an incredible sustenance. And in a place where it's not easy, the meat. You don't want to getting meat shipped from the mainland isn't the right answer either. So, yes.
Thanks.
Mhm.
It's very sad when a whale is hit by a big ship.
Yes.
How successful is the legislation being to calm this down, or lower the
Yeah.
numbers?
Not successful enough, I would say. There have been some efforts. There have been some good programs like Whale Alert and others that let mariners know when whales are in the area. It is still very controversial. Speed restrictions on whales. It's known that reduces ship strikes, but of course there are trade-offs to going slower. So there's been some pushback, and I think we really need to think a lot more about either rerouting shipping, which has been successful in some areas. So you move the shipping lane when you can, and slowing ships down. We are good at stopping intentional whaling. We've been very good at that. We haven't been so good at stopping unintentional whaling, the whaling that's indirect. So there's the reality. We have a long way to go, I think, on that one. Peter, I see your hands up.
Yeah, thank you for a super interesting presentation. I'm curious what the reaction has been to your findings that whales are bringing nitrogen to the surface, for example, and that there's this sort of circulation that I guess some people were surprised for that discovery.
Mhm.
How have scientists, other scientists reacted, and also maybe other political organizations, maybe.
Sure. Yeah, it's a good question. It has been an interesting journey. So that first paper came out, I think it's 2011. So, it's almost 13 years ago now. And it was hard. Like we got hard reviews. It was questions at that time. And I still think there's a divide among marine mammalogists and biological oceanographers. So biological oceanographers tend to study microscopic and small organisms, and marine mammalogists, of course, study the big things. I'm happy to say that there have been several studies coming out here, including work by the Norwegians. And I went to a meeting at the International Whaling Commission where our work was challenged on this whale pump idea. They've been doing some work. They just gave a presentation showing that whales have an impact on primary productivity off the coast of Norway. And these are people that are working with whaling um, managers, right? So I've seen some nice changes. Let's put it this way, though. One thing is there aren't the much of the ocean does not have whales. Whales are found where there's a lot of food and where they breed. And if you go from where you're sitting, I don't know where you are, to Hawaii, unless you're sitting in Hawaii, most of that transit, you're not going to see a whale, and whales don't have much of an impact, right? But when you see whales, they can have a big impact. So the way we frame it is hot spots and hot moments. When whales are found, when they're abundant, they have a big impact. And it's certain times of year. A colleague of mine said it's like if you fertilize your garden in New York City, and you're going to have a big impact on that garden. But New York City, the whole city, it's not going to have that much of an impact. So in a way, I think the whales are having a large impact where they're found, but it's still a heterogeneous ocean, which I'm happy about, right? We don't want the ocean all to look the same. So I would say there's been probably movement from both views. Like, we're getting a little more understanding of the details. And I would say, I'd like to say that younger people are more accepting of this, just having gone to some meetings I've seen, like Next Generation, more open to these ideas. Thanks for that question.
Come on off mute. It's okay. Any questions? What's next for your research?
Mhm. Oh yeah, good question. So we just did that great whale conveyor belt. Well, um, we are looking at whales in the carbon cycle in part. So how do whales impact climate change? Spoiler alert, not a lot. It's kind of that answer that I just gave to Peter, is that they have an impact in areas where they're found, but globally, it's really up to us. It would be lovely if trees and whales could solve climate change, but it's really going to be about reducing the amount of CO2 we put into the atmosphere. So that's one. And then more controversially, I've been involved. We're holding a meeting on, you guys know it, I don't know how many of you are in California, mountain lion restoration in the East Coast. So talk about a hot topic. We're having a meeting in August talking about that. Our state mammal is the catamount. It's extinct. Here it's also, and so there's been some discussion. We are probably this is a long game. This isn't happening anytime soon. But that's sort of one of the policy pieces that I'm working on. And that was my first jump out of the ocean. So I've been sticking to the oceans here, but there you go. And I work on North Atlantic right whales, which I've mentioned throughout. It being a very important, the first species I ever studied, and one that's near and dear to my heart and needs protection. And the other one we work on is that Rice's whale, or the Gulf of Mexico whale, that I showed at the beginning.
Question for Michelle, is there a role of seaweed and kelp relative to whales?
Yeah, I mean, if we mean macroalgae, of course, if we broadly, seaweed can maybe include phytoplankton, and then huge connection. I don't know. Here I can tell you one connection, which is a very interesting one that was done by Jim Estes, who's a fantastic biologist who sadly died earlier this year. He was at UC Santa Cruz. He had a paper come out 10, 15 years ago that looked at the connection between the decline of sea otters, which resulted in an increase in sea urchins and a decline of kelp. So the disappearance of the sea otters impacted the kelp. So his work suggested that when we took great whales, the large whales, out of the North Pacific, killer whales no longer had their main food source. So they switched to seals. And when the seal populations declined, as I showed you, they switched to sea otters, and the sea otter populations declined again, and that would have had an impact on kelp. That's the only connection I can think of, but that doesn't mean there aren't 100 others. Most whales that I can think of do not eat kelp, so they don't direct whether they swim in it and use it for protection. I don't know. We've seen humpback whale moms use coral reefs on occasion as protection from killer whales. It's dangerous to go near a reef for a large whale, but for the mom, it might be worth it because you're protecting your calf. The killer whale's like, I don't, we're not going in there. You know, we can get a meal somewhere else. So those are some possible connections. I'd be open if you have some ideas.
Sounds reasonable. Any other questions? Yeah.
Just a comment. There was just a recent paper with the Southern residents breaking off bull kelp strands and using them as tool use.
Oh, cool.
Right.
Yeah, that's right.
So
Yeah,
that's
yeah.
that's a great use.
That is a
And
good one. Thank you.
you're
Mhm.
welcome. And fangirl.
Oh, thank
So thank
you.
you
Double
so much.
deep
This was
thanks.
absolutely
Appreciate it.
phenomenal. So
Oh,
appreciate
I appreciate it. Thank you for showing that. It made me
course.
happy. Mhm.
Very cool.
Great.
All right.
There was a question. I'm meeting with some behavioral scientists tomorrow. Do you have a question you'd be interested in having? Oh, to help address human behavior as it relates to whales.
Hmm.
Oof, that's a big question. I kind of liked ending on the on Dara's question there. Michelle,
No,
there are
no,
so
no
many.
pressure. No pressure on that
Exactly.
one. I'm just offering it actually for you or
Yeah,
Barbara, given some of the topics you're working on, is I
right.
meet with these people once a month and there's some of they're
Mhm,
just top behavioral scientists. And it's kind of like a round table and they always enjoy when
mhm,
you bring up a question and then they all chew on it and say, oh, well,
mhm,
here's maybe how we could approach changing behavior
mhm.
to do
Yeah.
something. So I know in a lot of these environmental topics or climate change, whatever, how do we change human behavior to
Yeah.
support something? So that's why I was just, don't worry,
Yeah.
it's a no pressure
No,
question. But if
it's a
somebody has
great
something,
one.
yeah,
Yeah. No, it's a great one. I don't know. For me, I think it's often storytelling. It's why I do this. That's an important part of how we convey this information. And I typically, this isn't really, it's answering my approach. I don't know about the behavioral scientists.
sure,
I do try and do a balance of positive solutions that have worked, but also not ignoring the threats. And for them, the question is like, where is the balance? Because I don't feel like, my message works for some people, but it doesn't work for everyone. So, I don't know. That's the question is storytelling and communications.
sure. Well,
Yeah.
Barbara, as you go off on your journey on what you're working on, if you think of something that it might be
Yeah.
helpful, because again, we're always
Yeah.
trying to get advocacy, and you don't have to get everybody on board, right?
Right.
You just
That's
need
right.
to,
Good point.
because
Yeah.
it's too exhausting. Not everybody needs to be on board.
Hmm.
But I also thought
Right.
that the sea otter example that you brought up, so positive legislation obviously has helped whales. And I'll tell you what, we have so many not great news stories right now.
Hmm.
People need to hear that change can happen and
Hmm.
hear those examples because I actually think it would encourage people like, okay, we can do this. And there's real value in that. Otherwise, people just give up and turn it off. But anyways, I thought your sea otter story was also interesting
Thank you.
of how they just picked them up and moved them.
Right.
Well,
Yeah, that
yeah,
rewilding. That was a very successful example for
sure.
sure.
Yeah.
Yeah.
Yeah, and I
Anyways,
think it's the misconceptions that we're uncovering here. Like I had no idea that they've recovered that well.
Hmm.
yeah,
Yeah,
So
it's important to know. And it's interesting because I mean, I feel like my students don't know it because they grew up in a world where, there's abundant humpback here in Massachusetts. Humpbacks are back, fin whales are back, gray seals are back, which is a little controversial because um, that means the white sharks have come back. For you all in California, you're used to white sharks, but Easterners aren't used to white sharks in their waters. So talk about behavioral scientists, that's been very example. And I see that Alyssa wrote that kelp is really important for resting gray whales. So thank you, spa days, especially with Pacific Coast Feeding Group gray whales. So thank you, Alyssa, for that. I didn't know that. So there you go.
Very cool. I thought I'd share my fun cartoon with you guys. If you give me 1 sec. Let me I saw this today. It was shared with me. I thought it was particularly appropriate.
Always
So,
love the far side.
yeah. So big thanks again to our speaker and to all of you for showing up and learning something new about what's going on out in the world. So I'm going to go ahead and stop our recording. If I can find my button. There we go.